Assalamu alaikum. Name Bisamir Rahman, ID 2301 Department BS Biotechnology. Submitted to Dr. Rahman Majid. Topic Dioctyl phthalate and dioctyl terephthalate. Table of contents. What is it? How is it made? What are its uses? Safety and regulations, balancing act, chemical breakdown, molecular structure, function group, isomer, chemical behavior, properties, applications, environmental effect, dioctyl terephthalate. What is it? DOP is a colorless oily liquid that belongs to a class of chemical called phthalate. It's one of the most widely used plasticizers, which are additives that make plastics more flexible and easier to work with. DOP signifies that a food product comes from specific geographical area and to traditional production method. This ensures the product quality and unique characteristic. How it is made. DOP is produced through a chemical reaction between phthalic acid and 2-ethyl hexanal. DOP is chemical compound synthesized through a chemical reaction. Here, simplified. Raw material and reaction. Raw material, the main ingredient are phthalic anhydride and 2-ethyl hexanal reaction. These components are combined in a reaction whether often with a catalyst like sulfuric acid to initiate the chemical reaction. Neutralization after the reaction, remaining catalyst and unreactivity phthalic anhydride and neutralized using an alkaline solution like sodium hydroxide. Separation mixture is then allowed to settle, DOP being an oil-like substance from a separate layer. Purification, extracted DOP might undergo further processing like washing with water, decolorization with activated carbon, and filtration to desired quality product. What are its uses? Primary use of DOP is a plasticizer in PVC plastic. It makes PVC softer and more manageable during manufacturing and final use. Flooring, coating material, wires and cable, toys, medical tube. DOP also has other applications such as dielectric flood in capacitor, hydraulic flood, and solvent for some chemicals. Safety and regulation, safety concern, potential health effects. Studies have suggested possible link between DOP exposure and health issue like disruption of hormone function, particularly in developing features and children. Environmental impact, DOP can leach out of PVC product over time, potentially contaminating soil and water. Regulation and restriction. Europe, the European Union registration, evaluation, authorization, and restriction of chemical reach. Regulation restrict the use of DOP in certain children toys. US CPSIA, US Consumer Product Safety Improvement Act CPSIA, toys at specific construction level. Balancing act. Finding alternative focus is on developing safer plasticizer that can replace DOP in various applications while maintaining similar properties. Ongoing research. Scientific research continue to evaluate the safety of DOP and other plasticizers. Chemical breakdown. DOP is diester, a type of organic compound formed by the reaction of diacid with two alcohol group. Its chemical formula is C2H3804 with a molecular weight of 390.56 g mole. Chemical breakdown dioctyl phthalate in detail. Molecular structure. DOP is diester meaning formed by the esterification reaction between diacid and two alcohol group, diacid and alcohol. Phthalate Phthalic acid C6H4COO2. It has central benzene ring with two carboxylic acid group, alcohol 2-ethyl hexanal. This 6 carbon chain alcohol has an ethyl group C2H5 attached to second carbon. Esterification reaction between phthalic acid and 2-ethyl hexanal involve the removal of hydroxyl group from each alcohol molecule and hydrogen atom from each acid group. Here simplify equation. This reaction form two ester linkage between the central benzene ring and remaining alkyl chain ethyl hexanal function group. Ester group, these are the central linkage formed between the phthalic acid and 2-ethyl hexanal. Alkyl chain CH17. These long brown hydrocarbon chain contribute to DOP hydroxide and oily character isomer. DOP is a mixture of several isomers due to the branching present in the two ethyl hexane structure. These isomers have slightly different physical properties but similar chemical functionalities. Chemical behavior. DOP is generally stable under normal condition, hydrolysis, thermal degradation, and oxidation. Hydrolysis at high temperature or in the presence of strong acid and base, DOP can break down into its original component through hydrolysis. Oxidation. Slow oxidation can occur in the presence of light and oxygen, potentially leading to chain and formation of phthalate monoester properties. Physical. DOP is colorless to slightly yellowish, oily liquid with a mild odor. It has high boiling point and low volatility, meaning it does not readily evaporate. Physical properties. State, odor, density, melting point, boiling point, and solubility. Volatility, viscosity, and flash point. Chemical properties. Chemical formula C24H3804. Molecular weight 390.56. Chemical stability, stable under normal condition. Electrical properties, weak electrical insulator. Plasticizing properties, reduce intermolecular force in polymer like PVC, making them softer and more flexible. Achieve this by inserting itself between polymer chain, increasing the distance and reducing attraction between them. Exhibit good resistance to heat and UV light. Plasticizing action. DOP function by interrupting the strong intermolecular force present in plastic chain, particularly PVC. This allows the chain to move more freely, resulting in a softer and more flexible plastic. Intermolecular force in polymer chain. Polymer chain PVC, like many polymer, consists of long chain-like molecule made up of repeating units. Van der Waals force, weak attractive force between temporary dipole in uncharged molecule, hydrocarbon hydrogen bonding, occur with the hydrogen atom bound to a highly electronegative atom with another electronegative atom in nearby molecule. Impact on polymer properties. Reduce stiffness. With weaker intermolecular force, polymer chain can move more freely past each other. Enhanced processing. The reduced intermolecular force also make it easier to produce the plastic. During manufacturing, DOP allows the plastic to follow more readily under pressure and heat, facilitating shaping and forming into desired product. Improve elongation. DOP plastic polymer can undergo greater elongation before breaking compared to an unplasticized variant. Factor. DOP concentration. Amount of DOP added significantly impact the plasticizing effect, but can also negatively affect other properties like strength and heat resistance. Molecular structure of DOP. The long branch chain alkyl of DOP contribute to its plasticizing efficiency. However, the specific isomer composition within a DOP mixture can slightly influence. Limitation of DOP as a plasticizer. Migration. Over time, DOP can migrate out of the plastic, especially at high temperature. Environmental concern. DOP is persistent organic pollutant with potential health and environmental risk. Regulation and becoming certificate to limit its use. Alternative to DOP. Due to this limitation, there are growing interest or alternative plasticizer with improved safety profile and reduced environmental impact that minimize migration and environmental concern. Applications. Coating material. DOP is used in some paints, varnish, and lacquer to improve flexibility and adhesion. Cosmetic. In the past, DOP was used in some cosmetic formulation as solvent as plasticizer. Pharmaceutical. DOP may be present in some pharmaceutical product as a processing aid and excipient. However, regulation and safer alternative are increasingly limiting this use. Food packaging. While not directly added food, DOP can potentially migrate from packaging material. Primary application. DOP main application is an plasticizer in PVC plastic. By disrupting the strong intermolecular force with PVC chain, DOP make the plastic softer and more flexible. Easier processing. DOP plasticized PVC is easier to shape and form during manufacturing, reducing energy consumption and production cost. Enhance food product functionality. DOP allow for the concentration of wider variety of PVC product. Coating material, medical tubing, children toys. Other application, dielectric fluid DOP weak electrical conductivity make it suitable for use in some capacitor as a dielectric fluid with help to isolate the conjunctive plates. Solvent DOP can act as solvent for certain chemicals such as those used in glue stick. However, due to safety concern, alternative solvent are used increasingly favored. Limitation and decline are in use. Health concern. Potential endocrine disruption and other health risks associated with DOP exposure have led to stricter regulation and decline in use. Migration. DOP can migrate out of plastic over time, reducing its effective and potentially cause the plastic to become brittle. Alternative safer alternative plasticides that derive from renewable resource with improved safety profile are being developed. Persistence and accumulation. Persistent. DOP is a persistent organic pollutant. This means it breaks down slowly in the environment, remaining active for extended period. Impact on aquatic environment. Toxicity, toxic, toxicity to aquatic life. When DOP liquor from landfill or improperly dispose of product, it can enter water bodies. Even at relatively low concentration, DOP can be toxic to aquatic environment, affecting their growth reproduction. Disruption to ecosystem. Presence of DOP in aquatic environment can disrupt entire ecosystem by harming various organisms. Overall impact. Environmental effect of DOP can signify and pose a long-term threats. Its persistent bioaccumulation and toxicity to aquatic life can disrupt entire ecosystem. DOP containing product become even more critical to minimize. Additional consideration. Endocrine disruption, while not directly an environmental effect, it's worth not nothing that DOP potential for endocrine disruption in wildlife can have a cascading effect on ecosystem. Health concern, potential health concern of DOP exposure are the subject of ongoing research. Endocrine disruption, DOP may mimic hormone in the body, potentially affecting development, reproduction, and metabolism. Other health effects studies suggest potential link to respiratory problem, allergies, and concern cancer, but not research in need. Conclusion. DOP stand out as non-phthalic plasticizer, offering a safer alternative to traditional option with pollution health concern. Application from polyvinyl chloride pipes to cable coating and numerous consumer good DOP further future potential. As the focus on safer and more functional material, DOP is well to play a significant role in shaping the future of various products. Dioctyl terephthalate (DOTP) define. DOTP is a chemical compound belonging to class of carboxylic acid ester. It's especially classified as a phthalate-free plasticizer commonly used in plastic products. Chemical formula structure. DOTP is an ester formed by the reaction between terephthalic acid and 2-ethyl hexanal. Terephthalic acid is an aromatic dicarboxylic acid, while 2-ethyl hexanal is a branch chain alcohol. Physical properties, appearance, color, clear colorless liquid with a slight outdoor molecular weight 390.57, boiling point 400 degrees Celsius at 760 millimeter Hg. Specific gravity 0.984. Solubility in water very low, around 0.4. Viscosity, relatively high viscosity compared to water, but exact value. depend on temperature and formulation. Flash point above 200 degrees Celsius. Thermal stability. Good thermal stability compared to some other plasticizer. Some additional point to consider. DOTP has a high boiling point indicating good thermal resistance during processing. Its low water solubility makes it less prone to leaching out of plastic compared to more water soluble plasticide. Flash point indicate DOTP can be flammable at high temperature, so proper handling and storage procedure are necessary. Chemical properties. DOTP exhibits several key chain properties. Chemical reactivity. Stability and reactivity. DOTP is generally stable under normal storage and processing condition. Reactivity, it's react with strong acid base and oxidizing agent. Other chemical properties. Ester functionality. Presence of ester group contribute to its plasticizing ability by interacting with polymer chain and increasing flexibility. Low water solubility. Its low solubility in water minimize leaching from plastic material into water environment, potential endocrine disruption. Recent studies suggest DOTP might have some endocrine disrupting potential, although its exact impact is still under investigation. Additional consideration, hydrolysis and degradation. Like most organic compound, DOTP can degrade over time, especially under exposure to high temperature, sunlight, or strong chemicals. Mechanism of plasticization. Polymer chain. Plastics are formed by long chain like molecule called polymer. These chains tend to line up and form rigid structure due to intermolecular force like hydrogen bonding and van der Waals force. DOTP molecule with their long flexible structure and insert themselves between polymer chain increase chain mobility. Weaken interchain follow force allow the polymer chain to improve more freely past each other. This increased mobility translates to a more flexible and less brittle plastic material factor. Size and flexibility. Long branch chain structure of DOTP allow it to effectively penetrate and separate. Low volatility, as mentioned earlier, DOTP allow volatility minimize migration from the plastic, ensuring long-lasting plasticization effect. Impact of plasticization on properties. Flexibility. Primary effect of plasticization is increased flexibility and reduced stiffness of plastic. Processability, improve flexibility during processing, allow for easier shaping of plastic during technique like extrusion or injection molding. Lower brittleness. Lower brittleness plasticization reduces the plastic tendency to become brittle and low temperature potential drawback, while beneficially excessive plasticization can lead to reduced mechanical strength, increase creep change in surface properties. Optimization plasticization with DOTP. Type of polymer being plasticized also influence DOTP effectiveness. Compatibility between DOTP and the polymer is critical for achieving optimal results. Primary application. DOTP is widely used plasticizer for PVC building and construction, PVC pipe profile for window and door, flooring material, roofing. Automotive industry, consumer goods, toys, footwear, house and coating fabrics, food packaging film for food wrapping, although regulation and limitation exist due to potential migration concern. Additional application of PVC. Paints, lacquer, ink, and coating. DOTP improve flexibility and adhesion property in the formation. Other polymer, while primarily used with PVC, DOTP can find limited application in some other polymer like synthesis, certain nylon factors. Desired properties, specific property need in the final product influence the choice and amount of DOTP use. Regulation and safety. DOTP regulation and safety considerations, especially in application like food packaging, need to carefully evaluate environmental consideration. Biodegradability of DOTP is low and its environmental impact need to be factored in during disposal. Advantage of DOTP. DOTP offers several advantages over traditional plasticizer. Safety advantage. Reduced health concern compared to some DOTP is generally considered safer. due to its lower potential for endocrine disruption. This makes it is a preferable choice for application like toy and medical product where human health is primary concern. Environmental benefits: low migration and biodegradability. DOTP lower volatility compared to some plasticizer minimize its migration from the plastic product. Performance advantage: excellent plasticizing power. DOTP effectively increase flexibility and processability of plastic, making them good thermal stability. DOTP exhibit good thermal stability compared to some plasticizer, allowing it to perform low water solubility. Its low water solubility minimized to risk of plasticizer leaching from the plastic. Regulatory advantage: compliance with restriction. DOTP is generally considered compliant with various restrictions on phthalate plasticizer in application, toys and food packaging. This makes it future-proof option for manufacturing. Additional advantage: versatility. DOTP find use beyond PVC plasticization, showing some compatibility with other co-effective. While cost can fluctuate, DOTP can sometimes be cost-effective alternate to some other plasticizer. Disadvantage: potential endocrine disruption. While considered safer, recent studies suggest some endocrine disruption. Regulation and safety consideration, especially for food packaging, require carefully evaluation. Not a perfect substitute, may not perfectly match the properties of some traditional plasticizer in all application. Resource. Thank you so much.